Hey, everybody, and welcome to another episode of Biz Books. My name is Gene Marks. Thank you so much for watching and listening as well. I am glad that you are joining us today. Really fun book. I don't know if AI can actually be considered to be fun, but it is a very important topic for not only consumers but more importantly for business people that are running companies to understand the business case for AI. And that is the title of this book. It's called The Business Case for AI: A Leader's Guide to AI Strategies, Best Practices, and Real World Applications. The author is Kavita Ganesan. First of all, I should have asked you, Kavita, before I started. Ganesan is the right way to pronounce your last name. Is that correct?
Ganesan, correct. Yeah.
Perfect. Okay, that's great. So, Kavita, you're an AI advisor, you're an educator, you're a consultant. Tell us a little bit about yourself for starters and how you came to write the book.
Sure. So my background with AI goes long back to 2005. So that's when I got started with AI, and it started with my master's program at the University of Southern California.
Okay.
So at that time itself, they had cutting edge AI research going on. And I was exposed to the whole field of algorithm development and creative problem solving. And I was hooked. I wanted to do more of AI. So that's when I went back to do my PhD in the field. And then as I was about to graduate, data science as a field, which kind of uses AI, really started to take off. And I got into solving a lot of industry problems on the hands-on basis. And as I was doing that, other companies started contacting me to help them implement AI in their businesses. So that's how I got into more and more consulting roles. So I've worked in a lot of different roles, from academic research to hands-on implementation to working with C-suite. So, and I've seen a lot of the problems in the field in implementing AI into business. And that's when I realized that these AI initiatives, they're not failing because the problems was unsolvable. There were a lot of other issues like mismatched expectations or knowledge gaps. So my book is to address these knowledge gaps. So I wanted it to become the bridge to address the knowledge gaps.
Got it.
But it doesn't assume that you have any AI knowledge. So it starts with the very foundation of what is AI, what does it mean in the context of business, and then it works its way up to more complex topics like, should you build or should you buy? How do you find these AI opportunities? How do you measure the success of AI? So that's kind of how the book came to be.
That is great. And by the way, for all of you guys who are listening or watching now, I mean, hopefully we all realize that AI stands for artificial intelligence.
Yeah.
And AI is the acronym for it. So just to make sure that we're all clear on that. And so, Kavita, besides selling millions of copies of this book, what else? How are you earning your livelihood now? Do you consider yourself to be a consultant right now? And do companies hire you to come in and and recommend ideas and processes? Are you still doing, coding, how do you earn your livelihood right now?
My livelihood is primarily consulting.
Okay.
So companies need a lot of help in maybe implementing AI into their workflow. So a lot of times they have an idea, but they're not sure if AI is the right solution or how to even make a project out of this idea. So that's where I come in, because I understand the business side of things and also the hands-on implementation side. So I'm like right in between, translating business requirements into solvable pieces of project, AI project. Yeah.
It's funny, when we talk about AI. My father, he passed away back in 2005, but he was a developer himself. And I remember as a kid growing up, he talked to me about AI. In your book, you wrote that AI actually got its start in the 1940s. You think about it like it's such a current thing now. Everybody is automation and workflow and AI and machine learning, and but it goes back a long period of time. Like, what was it first? How was it first implemented back, post World War II? Like, what was it thought of to do?
I think the early systems were heavily like rules-based, so encoding human knowledge in the form of software rules. So it did not learn based off of data like the systems do right now. modern AI systems learn from large amounts of training data. So the examples, and it looks for patterns in those data, and then it comes up with like a mathematical function to make predictions on new data. So it started off very rules-based, and then it progressed into more data-driven. And actually, AI has had its summers and winters. So every time computation power is insufficient and research hits a plateau, they go into AI winters. And then when computation power becomes more available, then the research starts to take off again, which is how deep learning, have you heard of deep learning?
I have, which we're going to talk about in a minute.
Yes, and deep learning gained its popularity just recently because of computation power that became available like in 2011.
Yeah.
And this was in the form of like cloud-based instances where you can borrow computing resources from the cloud, really.
Right. Understood. Understood. Okay. So there are, in your book, you say there are 5 topics that really kind of make up AI. You talk, deep learning is one of them. Machine learning is one of them. Computer vision, robotics, and natural language processing. So I think it would really be helpful for all of us to, for us to go through those 5 topics and have you, one by one, sort of give a definition of each and maybe an example of each. So no need, I can prompt you. This is easy. Like, let's start with machine learning, right? Which you also call ML. What is it? And give me an example of where we see machine learning in real life.
Okay, so just to provide some context, people often think AI is one thing,
right?
But it's actually different sub areas of study that come together to solve specific problems. And you can use these sub areas that you mentioned in isolation or in combination.
Okay.
So machine learning, for example, algorithms that learn from data. So let's say you're trying to make prediction to see if a credit card transaction is fraudulent or not. So you learn from a lot of different data points on what makes a credit card transaction fraudulent and what's a legitimate transaction. So based on the example, the algorithm forms its function. And the next time a transaction comes in, it knows, okay, with this 98% probability, this transaction is in fact fraudulent. So it's very data driven.
So that's just to give an example. I'm just thinking about that also, like in my life, like my wife is from England. We travel to the UK a few times a year. I remember initially we would go to the UK and our credit cards, we charged something over in London and we would get questioned on it. Like what the credit card company would ask what's going on. This is years ago. We don't get asked those questions anymore. It's almost as if the credit card companies have gotten smarter. They're using machine learning to figure out that, hey, this person's transactions we see multiple times a year. This credit card holder does go to the UK and is, so it's not an unusual thing that we need to flag. Is that an example?
Yes, and also when you travel, you're using your credit card to buy those tickets. Yes. So it has that information that maybe you have traveled to the United Kingdom. So then it makes sense that the credit card transaction is valid in that country. So it does a lot of analytics and AI, yes, behind the scenes.
Got it. Okay, that's great. Were you going to say something else about machine learning? Because that really brings
and within machine learning itself, there are different classes of machine learning. Like there's something called supervised learning, where you need to know the correct answers. So if a transaction was fraudulent, you need to know, you need the data for attributes that led to a fraudulent transaction. So the correct answers need to be provided. But there are some algorithms where you don't have to provide the correct answers. It just figures things out. So this is called unsupervised learning. So these are 2 broad classes. And the newer models, like you may have heard GPT-3 and generative AI, that are being thrown out in the news. So these are called semi-supervised learning systems. So these systems learn from large amounts of web data, and it can complete tasks for you without you having to train the system again. So you can use this system to maybe do sentiment classification or do sentence editing, copywriting. So these are semi-supervised. These learn from large amounts of web data. And these are the newer types of generative systems.
Got it. Okay, that's very helpful. Let's go to the next one, which is deep learning. Tell us about that.
So deep learning uses is like a subset of machine learning, which uses something called neural networks behind the scenes. And the intuition is that it mimics the way humans have connectors in our brains to make decisions. So that's the whole thinking behind neural networks.
Okay.
So it's mimicking how we humans make decisions.
Hmm.
And the way machine learning differs from deep learning is that deep learning can find which combination of attributes can learn a specific prediction. It learns the weights automatically. It learns which attributes to use. Whereas for machine learning, you need to say use maybe attribute X, Y, and Z to make predictions.
Is deep learning like is like autonomous vehicles like a form of deep learning, because it's not only using data that might be in a system, but also all sorts of data all around a vehicle to make decisions as to which way to move the vehicle.
There are different uses of deep learning within a self-driving car. So in order to see obstacles and objects on the road, it uses computer vision paired with deep learning to make those decisions.
Got it. And you know, it's we'll get into this also a little bit later in the conversation, I hope, but you know, all of this machine learning and particularly deep learning, I mean, my understanding is that it takes a lot of hardware, a lot of processing, right? I mean, what I listened to this great interview. Is you must know Lex Friedman, right? Who does a great podcast, and and he's an AI, and he interviewed Elon Musk like about a year ago, and you know, even Elon Musk was saying how challenging it was to get Tesla to do its autonomous, you know, with its autonomous vehicles, because he said it's a combination of machine learning and deep learning, but the processors that are needed, the hardware, you know, to put into a car to make a split-second decision not to run over a puppy, you know, he said it's really hard.
It's really hard, yes, and because these deep learning networks are so complex, they can sometimes take time to make predictions. It's not instantaneous. So there's a trade-off between making a prediction fast enough versus making an accurate prediction. And that's hard in a self-driving car, because these things need to be embedded within the vehicle itself.
I think about that as well, like Kavita, like I was just about this the other day. I was walking through an airport, and I was walking through like a terminal, and there's masses of people walking towards me, you know, and I just happened to bump into a friend there, and I was thinking to myself like afterwards how like there's just thousands of people coming by me, and my brain is able to like instantaneously determine that like don't know this person, don't know this person, don't know this person, don't know this person. I know this person. Do you know what I mean? And I think about like the power of like the human brain, like that can perform those levels of processing and functioning. And what would be needed for a computer to do the same thing just seems like just a huge challenge, you know?
Yeah, it is an uphill battle, and we are trying to make AI more and more like humans, but we're not quite there yet, especially when it comes to like common sense reasoning. We're just not there yet. It's still memorizing based on data and weights. So the common sense reasoning component is still being worked on.
Okay, so we talked about machine learning, we talked about deep learning. These are components, like sort of like the building blocks of AI. Computer vision is another one that you say. Tell us about that.
So computer vision is all about understanding images and videos. So understanding what's within an image, what's within a video frame. So is there a stop sign? So that's how autonomous vehicles know, hey, there's a stop sign, maybe I need to slow down. So being able to detect these different objects is what computer vision is. And it's often paired with deep learning behind the scenes to learn from large amounts of images.
Facial recognition as well with that.
Facial recognition as well. Yep. Yeah.
Got it. So when I go, I'm just using the airport analogy because we just came back from the UK. So, you know, they have global entry now, and they really take a picture of your face, and like almost instantaneously you're like, okay, you can go through. That's an example of computer vision?
That's a very good example. In fact, I used it just recently.
It's pretty amazing. It really is amazing. It's for you to say it's amazing amazes me, because you're the expert in this, and you're like, wow, this shit really works.
Yeah, this is a pretty new thing. Like I just walked in and they said, go.
I know. I know. It's pretty impressive. It really is. Okay, so machine learning, deep learning, computer vision. We have two more components of AI. Robotics is the next one. Tell me about what robotics is.
So robotics is basically trying to take the different human functions and trying to use that within a machine to achieve specific tasks. So let's say there is a report of a bomb in a particular location. Then you can send this robot to put off this bomb, detonate the bomb. And the robot needs to understand a few things, like maybe human commands. So that's where natural language processing comes in, the intelligence part. It needs to understand how to move correctly. And that's another area of study within robotics, which is called sensing, I believe. So understanding how to move accurately. And then computer vision to see the object. So it uses all these different AI applications in a machine. So basically, it has an embedded computer within that robot. Yeah.
And is robotics and AI, sort of the technology that we're hearing now, like in warehouses and factories? Amazon is installing a bunch of robotics to perform the functions of humans. And I guess that uses a combination of computer vision and some type of machine learning, correct?
Correct. Yes. It used to be that robots were just mechanical machines, where just move object A from location A to B. But now it has more intelligence in it. Like it can actually see what the object is. So it's a lot more intelligent. Yeah.
Another, I'm thinking as well, just because this is all such real life stuff. When I walk around Giant supermarkets, I don't know if you guys have Giant out in Salt Lake, but there's a bunch of them in the Mid Atlantic area, and they have these robots that walk around the store. They glide around the store, and they're there. They have natural language. You can literally ask the robot like, what aisle is corn in? They can also identify if there's any spills on the floor or if there's any things missing from shelves. So to your definition, it's using its computer vision, it's using some of its machine learning to then notify the shelf needs to be restocked, or there's a safety issue on aisle 3, that kind of thing.
Yeah.
So that's advanced stuff. That's
advanced stuff, and it's super infused with AI.
Yeah, super infused. It's cool. Yeah. Okay, so the last topic that's underneath sort of the umbrella of AI is natural language processing. I guess this is voice. Tell us about that.
Yes, NLP is natural language processing, or NLP is all about understanding human language and corresponding with humans the way humans would with each other. So in the case of chatbots, it's all NLP. So you're understanding what the human is saying, and then you're responding in a way that makes sense. And NLP goes beyond just like chatbots. It can also be used to understand documents, business documents, and then categorize these documents accordingly. It can be used for sentiment analysis, so trying to understand what your customers are thinking about your brand. It can help you classify like support tickets. So which department should it go to? So there's lots of business applications of NLP, really. And yeah, we have a lot of text data.
We do. There's a lot of information that is done. And I guess one of the more common uses of that, Amazon Alexa, right? If you're, in your home, you are talking to Alexa and it's theoretically talking back to you. I guess that's a fairly good example of natural language processing.
Correct. Yeah. And that is called speech recognition. So that's a form of NLP. That's correct. Yeah.
Got it. Okay. That's great. All right. So listen, I'm going to jump ahead a little bit in the book as well, because I do want to get into some of the other concepts. And again, this is, the whole purpose of this conversation is to entice people to buy this book. There's a lot more detail in this book that we're not sharing, that we're not, so we just don't have time to do it. But but you have a whole chapter about maximizing AI success. And there is one part of that, you give like 5 tips for doing it. One of them is about addressing foundational gaps, which I found interesting. Can you explain, what that means?
Addressing foundation. Sorry, just a moment. My kid just came in.
Oh, that's fine.
Yeah.
No worries. This is why we pre-record this stuff. This is why we can always edit, move things around. It's completely fine.
Sorry. Yeah, could you please repeat the sentence?
No worries at all. So, one of the chapters, early chapter in your book was talking about, you succeeding with, with AI. In other words, maximizing your success. And you
Mhm.
give 5 tips. And again, if you want to buy the book so you can read the 5 tips. One of them, though, was about addressing foundational gaps. And
Yes.
I just wanted to ask if you could expand on what you mean by what a foundational gap is and why that's important to maximize your success with AI.
Yes. So in order to do AI, we need data. We need a lot of preparation elements essentially. So, and data is one big part of it.
Mhm.
So these are the types of gaps you want to focus on. So maybe your data readiness gaps. So maybe you're not aggressively collecting data. So you may want to start doing that, because you can't just go into an AI initiative without data, because that's going to be a non-starter to for your project. So that's one type of gap. Another gap is cultural readiness.
Right.
So there's a lot of fear around AI. So how are you going to address those cultural readiness gaps? So maybe you need to educate your employee and your customers on what is this AI thing? Why is it useful for the business? So you'd identify the different types of gaps. And I also talk about the 5 types of AI readiness gaps. One is cultural readiness. The other is budget,
Mm.
infrastructure, skills, and data. And I call this B-Kids in the book.
Yeah, it's funny because the things you mentioned, like infrastructure, is a perfect example. We just talked about that earlier. How you have to have that there, skills. Having the right people internally that can not only develop your AI solutions but also deploy them, which is really really important. You also talk about in the book about some myths about AI. People think that AI is going to eliminate jobs, and that's certainly a myth. It's not going to take over all jobs. I was hoping you could kind of elaborate on some of the myths of AI. One of them is about accuracy. You say that AI is rarely 100% accurate.
Correct. Yeah.
It's a myth that it's perfect. So what do we do about that? I mean, I thought the whole point of automating using AI is to make things better and more accurate.
Correct. Yeah. So every AI application has an associated accuracy to it. So if it's 95% accurate, there's a 5% chance that it's going to make mistakes.
Right.
And that's on data that it understands, it maybe has seen in the past. But if you feed it like suboptimal data, then the inaccuracies is going to significantly be higher. So let's take the task of like predicting the risk of lung cancer. Let's say it's trained on a lot of CT scans, historical CT scans.
Yep.
But if you provided an image that is suboptimal, it's not very clear, then it's going to make a mistake. So that's why we need to be very careful about how we use these AI systems. Just like humans, it can make mistakes, but the mistakes can be very different from the type of mistakes we make, because we have the context, we have the common sense reasoning, and some of those AI mistakes can be really silly. Like you'll be like, really, you made mistake on this simple thing? And you see a lot of that in self-driving cars. Like self-driving cars crash all the time because maybe it did not see the object on the road, or it thought the object was a stop sign or something like that. Of that
Sure.
nature. Yeah.
Yeah, it's and we always have to remember that AI itself, even though it was started in the 1940s, it's still a very, very young technology. And there is still a ways to go. And AI itself is developed by developers, and developers themselves make mistakes or have inadequate or incomplete tools.
Correct. Yeah.
And because of that, it shouldn't be relied on. And I guess that gets back to the one of the myths, saying like you shouldn't be thinking that AI is the be all and end all. Once you develop an AI solution, it's going to be this perfectly running, perfectly functioning thing. You have to you have to accept the fact that it's not going to be perfect, and mistakes will be made.
Yeah. And one thing to keep in mind is that these systems can be improved over time.
Yeah.
So maybe you start with a baseline system, and then you get more data that's representative of your problems. You add that to your model. So you need to be prepared for the long term for when it comes to AI. You can't just deploy one system and expect it to work for the next 10 years because your data will change, the regulations will change. So this AI thing needs to be updated very frequently.
I found now I run a small business, so there's no way that I can hire developers to develop AI solutions for me. You know, Kavita, like I normally tell our clients who are also small businesses, like, you know, if you really want to leverage AI, talk to the software vendors that you're already using right now, because those are bigger companies with more resources that are likely developing you know, AI types of functionality that you know, for their own customers that you can be taking advantage of, you know. Um, and a lot of my clients like, well, I don't even know where to start. Like, I don't know, you know, what benefits AI will bring to me or how they can improve my business processes. You had a whole chapter in this book that basically said, this is how AI can improve your business processes.
Yeah.
And you give examples by functionality in a business. And you know, you talk about how it can improve customer service and HR and sales and marketing and operations and manufacturing.
Yeah.
So let me pull out a couple items here just to give our listeners and viewers just a taste. Okay. So
Yeah.
let's talk about customer service. Well, you know, just start with that. How can AI improve, you know, your customer service operations?
So the nice thing about customer service is there's a lot of data. That's a nice part of customer service. And also there's a lot of inefficiencies and a lot of pre-established metrics like your average response times, first contact resolution rate. So that's how the service agents are measured in terms of performance. And because of these things, you can find areas where there's a lot of manual, repetitive work that requires human-like decision-making. So for example, let's say it's a problem of routing incoming support tickets. So a lot of companies still do this manually. The support ticket comes in, the service agent has to read the support ticket, understand it, and then route it to the correct department for resolution.
Right.
So this is a complex decision-making problem. It's repetitive. It needs a human in the loop. However, you can teach an AI system to make these routing decisions, and the productivity of the employee immediately improves because then they may just have to focus on the really difficult routing tasks or those that the AI could not handle. So they're supported by this AI system behind the scenes. And also you can operate with a much leaner team when you infuse AI into areas like this, where there's lots of manual work, it's very repetitive, and like human level decision making is required. So like routing is one area. Another area is in corresponding with customers and answering their common questions in the form of like virtual assistants. So let's say customers have questions about what documents to fill for a particular problem. So you can ask this question through a chatbot, and it will immediately understand that what this is about, and then give you the link to that form. And as a result, the number of incoming support requests will significantly reduce because the AI agent is already handling a lot of these common requests. So it improves the efficiency of your service operators in general. So they focus on the harder tasks.
You know, it's, I'm going to interrupt you. You know, you make me think of my experience. Like you know, we had a dog who she passed away a couple of years ago. Her name was Lavender. I did not name her Lavender, Kavita, by the way. That was my wife's name for her. Okay? And but she was a sickly dog when we got her. We got her from like as a rescue. And we had her on all sorts of medications. So became very, very close with our local CVS pharmacy. And I would get texts from CVS, unannounced. Just they would text me and say, "Hey, Lavender's prescription is coming due. Do you want to renew it?" And I would text back and be like, "Yes, please renew." And then they would text back and say like, "Oh, you're out of renewals. Would you like us to contact your vet?" And I'd be like, yes, please contact your vet, contact our vet. And then it would text me back, saying we've contacted your vet and we've renewed your prescription. You can pick it. Where would you like to pick it up? Would you like it mailed? I don't know. We'll pick it up. Anyway, I'm pretty sure I was talking to a bot the entire time. I'm pretty sure this was an AI generated, you're using like customer service and transactional, whatever. That's probably true.
I
right?
think you are right. These are type of things that the AI can handle. It understands your request, then translates it into a database query, then it queries database and sends back a response like from a human.
Yeah. And it's and it's a common, clearly it's a common type of conversation. I mean, CVS has, millions of customers that just have to renew prescriptions. And it's unusual. And I'm assuming if I were to ask a more complex question, like, oh, if I give, will this medication interfere with something else, or I have a whatever, I'm assuming the bot would be intelligent enough, the AI behind the bot would be intelligent enough to say, hold on, let me connect you to a customer service representative, right?
Correct. Yeah, and I don't think CVS can support millions of customers that answer those kind of common questions. So it makes sense that they would use a bot behind the scenes.
Okay, we're going to get into, because you do talk about the book, like, later on, like I some of your advice on building these types of applications, but just because, just again, for our listeners and for our viewers, that's customer service. That's great. How about manufacturing operations? I'm curious about that as well. You give some examples in the book, like, how does AI help in the manufacturing process if you're a business manager or executive or an operations person?
In a few ways. One is in the manufacturing line itself. So there can be lots of defects in manufactured products. And the human eye may not be able to detect the really small defects, like we can see things that are large enough for us to see. And we often miss things because we are sometimes distracted and, we are being called into different meetings. But the AI system can see really minuscule abnormalities in the form of images. So by feeding it images of the product, it can detect, hey, there's a defect here and there's a defect here. So by doing this, you are proactively finding the defects in the manufacturing line. So, and you're preventing it from going down further the manufacturing line. So so there'll be less returns from customers. There'll be less remanufactured parts. So you're going to save lots in terms of revenues just by proactively detecting defects early on. That's one use of AI in manufacturing.
Fascinating. Keep going.
Another use is in trying to predict when a machine is going to fail.
Okay.
So just by looking at historical parameters of the machine and when it failed, you can preemptively predict failures that are going to happen. So what the company can then do is maybe schedule maintenance at a time where no manufacturing is happening, as opposed to interrupting the whole manufacturing line, which costs them millions of dollars in lost revenues. So AI has a lot of power in manufacturing.
It does. Now, as I said earlier, if you're a smaller business and you're looking to leverage some of that automation, even in the manufacturing process, I mean, my recommendation is to go to if you have manufacturing software already, Dynamics or Sage or Epicor or something like that. I think it's a pretty good bet that those people are developing these solutions. And you should probably be going to them and saying, what do you have? But okay, say you're a larger organization, or say that you really have a very unique application that you want to leverage machine learning to improve a process. You lay out these sort of 6 phases of a development project. You say that it's problem definition, and then it's data acquisition, and then it's model development, and then post-development testing, and model deployment, and monitoring and feedback. Walk us through that development life cycle. I named 6 phases. So in 30 seconds or less. No, I'm just kidding. Just give us some of your thoughts on having a project like this and deploying those 6 phases, and what things a manager should be keeping in mind.
Yeah, so the first thing is to understand that you do have an AI problem,
Mm,
because often we think that a software automation problem is an AI problem, which is not the case. Most software automation problems can be solved with just software engineering,
right.
and very specific problems that, like I said, requires complex decision making. It's repetitive, it's high volume, and requires human-like decision making. So those tend to qualify for the use of AI, like natural language processing and machine learning. So once you've identified the problem, you need to actually lay out like the building blocks, not the building blocks, the details of the problem. So what pain point are you solving? So that's where the problem definition comes
Right.
in. So once you outline the pain point, you know what metrics you could potentially track when you deploy this AI system. So the problem definition piece is the most important, I say, when it comes to AI. And then you need to figure out if you have the supporting data for the initiative, because that's how these AI systems are built today,
Yeah.
using large amounts of data. So if you don't have the data, you have to go acquire that data first. So that's the data acquisition step. And once you have these problem definition and data, then comes the prototyping. So trying to build a model to solve the problem. So that's the model development phase.
I'm thinking, so I'm going to just stop you right there. The
Yeah.
data acquisition part that you mentioned, I mean,
Mhm.
this is machine learning. And you said earlier, it's all based, it's learning from the data that you have.
Mhm.
That's how AI works. If it doesn't have any data to work off of, it's not going to work. So
Yeah.
that's important to either acquire it or have a process for building it. So your application can learn from it. And then that, once you do have that, and then you want to develop this model, I'm thinking of flow charts. Is that right? Like if this, then that, if the answer is yes, you do this. If the response is no, you do that. Is that what you mean by model development?
So model development is, in the context of the ML development lifecycle in my book,
Okay.
is using AI algorithms, like machine learning algorithms, to learn from that data. So basically you set up the data in a way that the machine learning algorithm can learn from. So let's say you're trying to predict the price of a home in a particular area. So maybe
Right.
you have different attributes like the size of the house or the historical price of the house and things like those are the attributes. So you set up the attributes and then you set up the correct answer, the labels. So then the algorithm looks at the data point and the corresponding labels, and then it learns how to make predictions on future data. So that's what the algorithm does. It uses the different mathematical functions, the different probabilities, the different weights. So it decides how to learn. So different algorithms learn differently. So that's the development part. Yeah.
Got it. So you develop and then you start testing, correct?
Correct. Then before deploying, you want to test it with real users in a real scenario.
Sounds like
So
a good idea.
Pardon?
Sounds like a good idea.
Yeah, like real, I guess, beta users, not really customers. So because you want to see how your model behaves with real life situation, you don't want it to go out into production and start failing. And the data in real life is often slightly different from the data it's trained on. So try to gauge what's going on there. And also try to see whether it's really moving the needle in terms of the business metrics that you have set up. So if it's promised to reduce the time to complete a task, is it really doing that? Or is it creating more friction in the workflow? So once you've made sure that it's looking good, that's when you'll deploy the model fully into production. And once you've deployed, that's not it. You'll have to keep monitoring this model because the performance can drop with time. Like I mentioned earlier, the data distribution of data can change. The regulations may change. Your customers may change, so they are feeding it with different data. So you want to keep monitoring this model. And if anything bad happens, like the performance goes below expected thresholds, then you'll want to take this model apart and see what's going on. So that's where the monitoring comes in.
Kavita, who's the like? What kind of team do you need to have in place to do this? I mean, like, give me what type of skill sets would you think a company has to make sure their people have, or the team members have to have, to
Sure.
implement a machine learning solution like this?
Yeah, to start with, you need a business stakeholder who's having that particular pain point. Like
Okay.
it can be a customer service agent or a group of customer service agents having this problem and their manager. So
Okay.
they want to provide input to the data science people. Then you need to have the data science team, which can be just one person to start with if you're a small business. And then to productionize models and to support the data acquisition and all of that, you may need a person called a data engineer who does all the collecting the data, making sure the data scientist gets the data that they need. And then maybe you need software engineers to integrate the model into your workflow. So you always need a business stakeholder. You need some data scientists and data engineers, and maybe software engineers to integrate all of this.
And I'm assuming also some testers as well, maybe some people that know nothing other than just using,
Yeah.
to emulate what customers would be experiencing, right?
Yeah, and for larger companies, the models may have to go for review, like
Yeah.
maybe to test it for bias and potential risks and the bigger implications to the business.
Got it.
So yeah. Mhm.
And are these standalone applications that are written using, whatever code that might be available today, or software language, C# or whatever, that are just pulling on data from different sources? Is that how they're generally deployed?
Mostly it uses the tools today mostly use Python,
Okay.
and these tools, the different layers of abstraction, like Amazon provides some tools that are really easy to use. You just specify the data source, the type of model, and then it does the deployment for you. So it depends on how you've
So maybe it's about, so does that mean it depends on where your data is hosted? Like Amazon will provide those tools if you're on AWS or Amazon Web Services. Does that make sense?
yeah, it depends on the tools you decide to use as a company. So you
Right.
can just develop everything from scratch, right? From the algorithms.
Right.
You can reuse libraries,
Right.
Python libraries, but you may decide to develop the whole deployment architecture yourself. But you could also use third-party architectures like what's given by Amazon, so that they help you deploy, they help you monitor. And Amazon, Azure, and Google, they provide like easy to deploy AI platforms.
And I'm assuming that, well, you tell me, I mean, do you normally recommend to your clients that they take advantage of those tools? I mean, the more customized or proprietary your development is, the more risk that you're taking if one of your developers gets hit by a bus or disappears or whatever, that you could be in trouble. Whereas if you use one of these, tools provided by Amazon, their Python
Yeah.
tools, or Google, you've got more of a support infrastructure you could lean on if there's any adjustments that need to be made. Does that make sense?
Yeah. So what I recommend is if there is an off-the-shelf tool that doesn't require coding, like
Yeah.
speech recognition, there are many off-the-shelf tools.
Yeah.
So if you can use that and it works well on your data, that's the route you should take, because that simplifies everything. You don't have to manage any infrastructure with that.
Right.
But if you're prototyping something, I typically recommend just focusing on the prototype itself. So just staying off the different platforms, because that can add complexity. So once you know it works, then try to use one of the platforms available.
Makes sense. Makes sense. All right, Kavita, we're running out of time. This is just great stuff, and we've covered such a small percentage of what's in your book. Just a couple more quick questions. Tell me what B Kids are.
B Kids is the 5 preparation elements for AI, which helps you fill the AI readiness gaps in your organization. And it stands for budget, culture, infrastructure, data, and skills. And each one of these pillars have a different focus, and it helps you with the long-term adoption of AI. So for data, for example, you want to think about, are you warehousing your data stores? Because your data may be operating in silos. So a data store from branch A may not know anything about data store from branch B. But in order to do AI and analytics, you need to have a holistic view of your data. And if you're not aggressively collecting data, then you need to be doing that from the daily running of your business, because that's where you can start using AI and analytics. And also some companies are still, they're still operating based off paper processes.
Yeah.
But in order to do any sort of AI or analytics, you need all of the data in digital form. So start digitizing your paper processes. So just like this, with these different elements, with these different preparation pillars, I've provided some questions that you can ask to surface your AI readiness gaps.
So it's budget, culture, infrastructure, data, and skills.
Yeah.
And these are the 5 pillars that you need to make sure that you're basing any AI project around. One final acronym, and then I'll let you know. Tell us about what you mean by an MVP.
A minimum viable product is MVP. And in the case of AI, an MVP is a model that you can start using with your customers. And then you iterate on this model to make it better over time, because AI solutions they're not deterministic. They don't just operate the way you think they're going to operate. They'll give you many surprises. So MVP is a starting point. And then you get feedback from customers, you see problems with the model, then you iterate to improve the MVP. And that becomes your more full-blown solution.
The book is called The Business Case for AI, A Leader's Guide to All AI Strategies, Best Practices, and Real-World Applications. Kavita Ganesan is the author. Kavita, who do you want to read this book? Who is your target market?
I would say innovators, people who are looking to innovate in their company, the C-suite, you're trying to make your company more efficient, product managers, and line managers who are going to manage teams that are going to implement AI. All of them should have a high-level understanding of AI. And I think this book will be very helpful to these people.
Yeah, it was a great book. It was great knowledge for me. It is, again, like I said, most of my focus is on small and mid-sized businesses, but I do work with a few larger organizations that before they even get started, it's like, this is like a game plan, and sort of like a strategic book to know, like a must read before you embark on any AI project. It sort of just gives you everything in advance that you need to be considering, so you don't make any mistakes. It's really excellent. Kavita, you have 2 websites, opinosis.ai, opinosis.ai, and your own website for, I guess, your speaking and consulting. It's kavitaganesan.com. It's KAVITA-GANESAN.com. We'll be putting these websites up as well in our post-production so that people can read it. Hopefully it's on the screen as I'm speaking. But Kavita, this is it's great work. I want to wish you the best of success. You're in a field right now that is, you picked the right specialty, because it's growing and will continue to grow for many years to come. And I'm assuming, I'm pretty sure this will be the first of many books that you'll write about it as well. So thank you.
Yeah, thank you for having me, Gene. Thank you.
Everybody, you've been listening and watching BizBooks. My name is Gene Marks. I hope you've enjoyed this conversation. I will be back in another 2 weeks with another conversation with another great business books author like Kavita, discussing their new book offering, and how you can learn from it. So thanks so much for joining us. We will see you again next time. Take care.